Hello everyone. Welcome to yet another video on TwinSimulate. In this demo, we will look at how to control a 3D virtual car using a joystick with an STM32 board and visualize the control in real time using the Python bridge block and WinSimRT. Let's select STM32 as a target. Next, choose the STM32F103 board as a target subtype. In the left-hand side panel, scroll down and search for the STM32 library. Drag the ADC_DMA block onto the diagram. Next, add the serial out block. Since the joystick provides two analog signals, one for speed and one for steering, right-click both the ADC_DMA block and the serial output block. Increase the number of input and output ports to 2, and then click OK. Now connect the two outputs of the ADC_DMA block to the inputs of the serial output block. Next, double-click the ADC_DMA block to configure its parameters. Set the start channel and number channels according to the joystick connections. Then click OK. Now, double-click the serial output block. Set the data format to raw bytes so that the joystick data can be transmitted correctly. Then click OK. Next, open a new diagram. In the left-hand side panel, search for the communication library. Select the serial input block and add it to the diagram. Next, search for the bridge library. Select the Python bridge block and add it to the diagram. Now search for the RT-plot block and add it to the diagram. Since we are receiving two data values from the joystick, right-click the serial input block and increase the number of output ports to 2. Next, right-click the Python bridge block and increase both the number of input ports and output ports to 2. Similarly, right-click the RT-plot block and increase the number of input ports to 2. Now connect all the blocks as shown in the diagram. Next, set the sample time and final time as required. Now, double-click the serial input block. Select the appropriate COM port to receive the joystick data from the STM32 board. Then click OK. Next, double-click the Python bridge block. Browse and select the Python script used to control the 3D virtual car. Then click OK. Now, double-click the RT-plot block. Enter the appropriate curve names for the speed and steering signals. Then click OK. Now switch back to the first hardware diagram. Click Generate Code and Deploy. Wait for the code generation, compilation, and flashing process to complete successfully. Once the microcontroller is flashed and running, switch back to the simulation diagram and click Simulate. TwinSimulate will automatically launch the interactive 3D PyBullet physics environment alongside your real-time signal plot window. Now move the joystick. As the joystick is moved forward and backward, the speed of the virtual car changes accordingly. Moving the joystick left and right controls the steering of the virtual car. The joystick values are acquired by the STM32 through the ADC, transmitted over the serial interface, processed by the Python bridge block, and immediately applied to the virtual vehicle. You can also observe the speed and steering signals updating continuously in the RT-plot window during the simulation. This demonstrates seamless real-time communication between the STM32 hardware, TwinSimulate, the Python bridge block, and the 3D virtual environment. Thank you. Stay tuned for more TwinSimulate demonstrations.